I'm back, and we're back at Code and Graphic Stuff. Stoof. Today we are going to be doing uploading of 3D files. So if you have a 3D file, we're gonna make it so that you can render it fairly easily using all the functionality that we currently have. It shouldn't be that hard. If we go on Google and just type in Stanford 3D models, Stanford put together this, like, a bunch of these different 3D models, and I want to do OBJ files. Put together all these models so that we can take them and learn from them and utilize them for free. So we're gonna use them for sure because they're gorgeous. So let's here they are. So this one's so we have the bunny, the armadillo. See how many vertexes are on this? Could you imagine doing that by hand the way we've been doing it? Man, look at all the polygons they have. This one has color, so that's kind of cool. I'm just going to take all these and put them into a file because that's pretty sweet. Which ones did I get? Tyra, textured. Some of these are kind of big, it looks like, but I want to put them in a file. Ooh, the Tyrannosaurus. That's the F-16. Didn't give me the Tyrannosaurus Rex. Oh, that must be it. Okay. Just download all of them. Alright, just give me 2 bunnies. I don't want 2 bunnies. Alright, I'm going to these. Alright, so let's go to the downloads folder. Let's get rid of these duplicates. I don't want these. I'm just gonna. Alright. So we have the F-16. We have Suzanne. This. Don't need that. Okay, so we have the F-16. Textured F-16. I see, that's why. There's 2 F-16s. The Tyrannosaurus Rex, we'll want that. I know it looks like I'm downloading a bunch of stuff. Probably should have did this more. The armadillo, that guy's pretty badass. Blender Suzanne, and yeah. So I'm looking forward to having all these colors and stuff on it. Like, they actually come with color. That's pretty awesome. I didn't know they did that. This one has a texture applied with it, so we'll just utilize that. That's the cruiser. Do I have the cruiser? I don't have the cruiser. Okay. So while those are downloading, well, we should probably go talk about the object format. So in any one of these, I didn't get my favorite, which is the armadillo. The armadillo is by far the coolest. Oh shit, I already had the armadillo. Just took forever because there's so many vertices in the armadillo. Alright, I'm stopping you. Stop it. I don't want you anymore. I don't want you. Yes, okay. So, we have these files. Let's go check out the armadillo because he's gnarly. Okay, there he is. I'm actually going to do that for all these guys. Tyra, F-16, Suzanne, Bunny. Oh man, these are all pretty big folders. It's okay though, and then I'm gonna make a new folder on my desktop called 3D objects. You can't see it because it was off screen. Let me put it on screen for you. Go right here, and then I'm just gonna take all these guys and throw them in the 3D objects folder. Get rid of this. Utilize the 3D objects folder. All right, so I don't know if it's gonna load up or anything right here. But these are all .obj files, and what .obj files contain is a buttload of information about these. Oh man, see, oh cool, go Apple! About these 3D objects that Stanford has created for us. So what we're gonna do is we're gonna dive into. Look at that! Oh god, that's so cool. I'm gonna open one of these with Notepad or TextEdit, I guess. I need to really Okay, so it looks like we have it over here on this desktop. So here's the armadillo. Oh my god, it's so much information. So what we could do, there's several things we could do to read this information. We could parse this text file and like go letter for letter, row by row, and just figure out what the vertices are and store them. Or we can use Apple's beautiful Model I/O uploader. That's two things we can do. I'm going with the latter. Going to use the Model I/O because I don't right now feel like writing a bunch of code to parse this. However, if we're making our own true graphics, like graphics engine, we'd probably want to write our own uploader just to learn the bare essentials of what all of this information means. You'll notice, I'll show you how it's kind of parsed. Right here, we have, see how it starts with V? So these are the vertices, right? So it has all the vertices, just so many of them. These are the vertex normals. So you see how we go from V, and I'm going to keep dragging. We go V, now we're in the VNs. That's the vertex normals. So that's the normal to the vertice. Then we keep going down. There's some I don't really know. F's. So this is going to be the face. So this will tell you like what a face contains, like a triangle. So a triangle has a face, and it has to consist of at least 3 vertices and which way it's facing. This so that's face information. Keep going down. You'll see there should be like VT. Maybe. Okay, did I miss VT? Okay, apparently this one doesn't have it, but it has to be textured. So this one doesn't come with textured points, it looks like. VT, isn't that what it is? Let's try a different one. If I open up the bunny. Fine, VT. Huh. How about just the letter T? Yeah, there's only 4 occurrences. Where are you? The F16 had textures, right? So let's go to this one. Oh, I just opened it. Don't want to do that yet. You can do that. Check it out. These 3D objects are pretty cool. Let me see. Find VT. Yeah, here we go. So this one looks like it has texture coordinates on it, like we did last week. So it automatically applies those texture coordinates for the textures that it provides using these maps right here, which is pretty sweet. So it takes all of these guys, maps them onto the F16. So that'll be kind of nice to use today. And there's like some other stuff. So what we could do, we could parse this. Like it wouldn't be the worst thing in the world to parse. This doesn't even have that many vertices, it looks like. That's so much less than that armadillo. But yeah, we could parse this. However, we're not going to do that. We're going to use Model I/O. And what Model I/O does is it breaks down all these vertices into what's called a mesh. A mesh is just like basically a container for vertices, and because a mesh can contain submeshes, and then you can draw the submeshes index primitives. It's kind of a little complex, but I'm not going to make it complex because it's not supposed to be complex. It's supposed to be freaking easy. I wish it was just easy. All right, so let's dive into the code. Okay, before, after, we'll do it after. What are we at? Okay, so I'm already at 8 minutes 46 seconds to explain. I do want to do some code cleanup today because, I don't know, if we press play, I'll show you what I'm talking about. We're also going to do some code cleanup today because, oh man, my computer is the fastest thing on this planet. All right, so you see we have this, like the lighting. We'll have to go and comment out lighting if we want to get rid of lighting or change the different type of lighting. If we want to, we have a clear colored background, which is black, which is cool, but I'll have to go change the code in order to change that. So what I'm going to do is I'm going to add more UI elements down here so that we can do that from here rather than having to go change the code. And like whenever I'm on my desktop, this little light is perfect, but when I'm on my Mac, it's off-centered, and then I have to go and change the code, that off-centeredness. I'm going to put a little toggle for that. Shouldn't take too long. Also, like the way I've been doing this, I thought about this. This is ridiculous, but I have these in our Metal View classes. I have these functions that just call other functions that call other functions that are called the exact same thing. We're not going to do that anymore. We're just going to have a preferences class. I decided that's just going to have static variables so we can get them from anywhere we want. They're just going to be preferences. All right. So now that I've gone off topic off OBJ files, let's go back to OBJ files. Let's do that first. Ooh, this is going to be cool. This is what makes graphics programming so much fun, because you can just upload directly to your graphics engine any model you want that you create in Blender or anywhere. I'm not very good at Blender, but I do plan on learning it and then teaching you some Blender if you'd want me to do that. I think, I don't know. I'll make one. Maybe eventually I'll make one, and then I'll link this video to that. But in the meantime, what I'm going to do is make a new class. So it's going to be a node, and it's going to be called model. Just like we have a primitive or these cube plane nodes, etc., we're going to have a model, one of these, so that it's easily, new file, easily just make a model just like you would a primitive, just like you would a cube. All right, so it's going to be a Swift file, and it's going to be called model. Let's get into some code. Also, I got a comment on one of the videos, the coolest comment ever. What a sweet person. But I found out that so I've been uploading 720p because my computer can't really handle the exporting from the software that I use of 1080p, but I'm going to fight it and figure out a way to upload it as 1080p so you can read it better, and also hopefully my voice sounds good. He told me my voice sounded, I don't know what he meant, but I think I hear what you're saying. So I'm going to try to upload this as best as possible. Get this nice and crisp so you can read it. All right, enough talking. Shut up, dude. All right, so we're going to go import metal kit. All right, so this model is going to be class model. This model is basically going to be what the primitive is, except it's going to have different functionality, right? So what does our primitive have? Our primitive has all these vertex, etc. We're going to have all this, and also you see how we have to extend renderable and texturable, and that'll be it. We're not going to make any other protocols for model, not yet at least. So this should be fairly simple. We're going to call init. We're going to pass in the device, mtl device, just like we did before, and this time we're going to pass in the model name, and the model name will correspond to models that we have over here. So when that will be a string. Okay, so here's our init. I'm actually going to go open our Finder real quick and go to our desktop, take this guy right here, and just drag him over here and say finish. So now we'll have our models over here. Uh-oh, didn't want it to do that. So I'm gonna make a new group called models, and I'm gonna drag all these guys up into it. I don't want it to be in a reference folder. I want it to be in a group. And then I'm gonna delete this. Oh geez, it didn't work. Okay, let's try this again. Let's see, because like when you copy it over. All right, can I just do this? Add files. Yes. Here we go. Desktop. Yes. Add. Okay, it's gonna do that. Whatever, should be fine. All right, so now it's literally in here. Yes. Now we have our 3D objects. Hopefully, we'll find out. Okay, so we have our initializer, so we're going to call super.init. And yeah, let's do our extensions. Extension model for the renderable. That's going to need a function. Extension for model texturable, so we can add the textures, but we won't have any functions. Just like we didn't have any functions with the primitive, we won't have any here. We'll just need our renderable to call func draw and then wait for IntelliSense, and boom, you have your draw function. We're not going to fill that out yet. We're going to go up here, and it's going to complain because we need these things. So I'm not even going to do texturable. Sorry, I'm going to do renderable first. Texturable will come after that. So renderable has, if I can remember, we have var vertex function name equals that, var fragment function name equals that, and then we have var render pipeline state, boom, and then we have var vertex descriptor, and then we're going to need to make this vertex descriptor, so let vertex descriptor equal mtl vertex descriptor return vertex descriptor. All right. Oh, why would I do that? What are you doing? Vertex descriptor. Okay, so we have that. Stop complaining. Oh, nope, we need to instantiate some stuff. We need to go render pipeline state. And this is just like basic stuff that we've done before. Build pipeline state with the device. So that's going to take it in. And vertex descriptors already being good. What else do you want? You want something else? Super.members cannot be referenced in our root class. Oh, and we need to inherit our node. Okay, kosher. All right, so now we have models. That's how easy it was. No, it's not that easy. We've got more stuff to do. Our vertex descriptor, we're just going to go into primitive, copy that, because that's exactly what we need. This right here, we're going to take that, put it into the model. Right there, I'm going to mark just for reference to this position, color, texture, coordinates, and yep, that was easy. So now we have our vertex descriptor all set up. Render pipeline state is being built. We're going to use the same exact stuff for these. So if I just go take one of these, so we just need basic. We don't need anything fancy. We're going to change this to fragment. Fragment function name, we're going to use those vertex function names unless we do textures, which we're not doing yet, but we'll get to it. Yes, so I'm trying to think if that's it. What am I missing? Kind of itchy. Yeah. Oh yeah. So now, okay. So I mentioned something called meshes. Let's look up meshes because we're gonna need to build a mesh. And let's look it up. Let's go check it out on Apple's. I think they've redesigned there. I checked this out. Apple. I went to this Apple mesh thing just to make sure it exists. Is this what I typed? And it. Let me see. They've changed it, and it looks different. It doesn't look the same. They have different documentation, which is cool, I think. Apple mesh types metal Swift, maybe. Metal texture, Apple doc. Yeah, so here's this documentation. They have, it looks different if we can find it. Need to find meshes. Come on, Apple. Yeah, so here we go. Let's go to the MTK mesh. This is what we want. All right, so this mesh, a container for vertex data of a model IO mesh suitable for use in Metal app, which is what we have, a Metal app. So we have the initialization, and then here's the other. So here's the two things we need, basically. We need to initialize it to make a model IO mesh, and then we also will need to load the mesh from an asset. And our asset is going to be the vertices. Like, what are we describing this thing? So once we load from an asset, this is an MDL asset, and the MDL asset is literally all the once we'll get the file, and then we'll create an MDL asset, which is probably, let me see if the asset's on here. Once we have an MDL asset, the asset will contain all of the information we need for the vertices. See, so like, and not only that, it holds like all of this other stuff. This asset's pretty sweet. And then what we can call render on all of the asset's submeshes. So the asset will be the top parent. Underneath it, we'll have like meshes of different stuff, such as cameras and lights and vertices. The meshes will, and then the submeshes will have index primitives that we can then draw with. So it's kind of a hierarchy. I tried to find an image of one, but it's really hard to find. I do know that if you watch WWDC's Model I/O, I think it was 2015 WWDC Model I/O video, they did have a lot of hierarchical images. I haven't gone through it in a little while, but it'll be pretty easy to look at. But basically what we want is we want these meshes that contain all this vertex data, and we'll need to get those meshes from an MDL asset that will load from the object formatted file. Okay, so might have been the worst explanation of all history of explanations, but we're gonna move on with it anyway. So we have our vertex descriptor for this thing. So what we're gonna use, let's just do it. Let's see if I can do it. So func build model meshes. All right, so we want the model meshes, and then we're gonna have a freaking variable up here called var meshes, and that will be an array of any object, because like we said a long time ago, you can pass whatever the hell type of object you want into our GPU. You just have to describe it. Well, we're gonna describe what we have at, like, what our mesh actually is, using this function, which will be any object. All right, yeah, I'm just gonna keep going, stop talking. All right, so we're gonna take in the device, MTL device, and then we're gonna also take in the model name, which will be string. Okay, first of all, let's get the file, whatever file it is, and get it. We need to get it. So I'm going to call this var URL, well, asset URL. Like, where is our asset? Asset URL equals bundle.main.url for, I don't know if it's going to come up. It doesn't. Show me some stuff. Okay, it'll say for resource if you do URLF. We're going to use this one, model name, and then the extension is going to be obj. There we go. So now we have whatever file we pass in. So Armadillo this will be that file. Now let's create a vertex descriptor for our asset. Yes. So var asset vertex descriptor equals. Now we can make a vertex descriptor from this stuff, like the same exact stuff. We just need to call MTL and MTK model IO vertex descriptor from metal. So now we're gonna have a vertex descriptor for our asset, so that it knows what the hell the vertices are. Just like we have a vertex descriptor for the like this node, we have a vertex descriptor. We're gonna have one for this asset, and we're gonna use our vertex descriptor. See that? So now it knows that we'll have a position at the first, and then we're up at this offset, and then it knows we'll have a color at this offset and a texture at this offset. However, we still needed to define them a little bit better. So the best way to do this would be asset we need to define what the position, the color, and the texture coordinate is. So we're gonna go var. Well, this stuff can all be let. It's screaming at me. I don't like it. I don't like being yelled at. Let's see here. So let And then we're going to say let position equal asset vertex descriptor dot attributes. So we're going to get the attribute at 0, rename it, and then store it back in, which now that I'm thinking about it, might not be the best way to do this. So we'll need to say this is a MDL asset, or MDL vertex attribute. So this is an attribute. We're telling it it's an attribute. Now, what kind of an attribute is it? So position equals what kind of an position.name equals. So we're gonna tell it that this name of this one is the MDL vertex attribute position. Now, let's look through all of these. Look at all these. There's so many different things that you can say exist in one of these files. Look at, I don't even know what that word is. Not yet, at least. I'm sure we'll come by it. Bit tangent, joint indices. Look, joints. Like we can do animation stuff. There's occlusion values. You see, we have our texture coordinates. We see edge creases. You see, all of this stuff is like we're basically declaring it what that is. So we'll say position, and then we'll say asset vertex descriptor dot attributes at 0 equals position. So now that that's stored away, let's go ahead and do that for the other 3. So we need position, color, and texture coordinate. Oh, that's nice about coordinates. So I'm just gonna kind of copy this stuff. Copy that, put it here, take this, copy it, put it here, and then this would be 0, so this is the attribute at 1. Go model IO. Thank you for making life 100% easier. 100%. We would have to load this stuff ourselves. Kidding me? Jeez. Alright, so now that we have our asset URL and we have our vertex descriptor, we're going to need something called, actually, I'll just show you. So let's make our asset. So let asset equal mtk mesh. No, that's how we create the message. We need an model asset, MDL asset, right? Yes. And then let's look at these things. So we have a buffer allocator. We'll want the URL. We have an asset URL. Where is it? Vertex descriptor. We just made that. And then we're going to need what's called a buffer allocator. And the buffer allocator is basically going to make room for all that stuff. Maybe I'll show you. Oh, well, no, it's okay. So here it is. Why do I have double view on? Okay. So our URL is just our asset URL, and we're going to want to do that. Vertex descriptor, we have our asset vertex descriptor, and we're going to need to make a buffer allocator. So let buffer allocator equal empty. Wait, what does it want? MTK buffer mesh buffer allocator. Yes. And then just takes in the device. Nice. See that? Now I can just say buffer allocator. And we have an asset. We have a top, dude. This asset has so much cool stuff in it. So much cool stuff. Look, it has bounding box. Look at that. It has bounding box for collision. Maybe. I don't know. I made that up actually. It has children. It has, vertex descriptor. Oh, there's so much stuff in here. I'm not gonna go all the way through it, or am I? I don't know. There's a lot of cool stuff in there. You can look it up. Maybe we'll probably dive into it in the future for like doing animations and stuff. But for now, we just need this asset to load it onto our screen so we can see all of its cool vertices and whatnot. So now that we have our asset, we can set up our meshes, right? So we load our meshes from our asset. So that's going to require a try catch. So I'm going to just write this real quick. Let error as NS error. And then we can say meshes, meshes equals asset, no. All right, this is, so mtk mesh dot new meshes. Remember I showed you how it has those two functions. So the asset's going to be the asset, the device is going to be the device, and don't worry about the source meshes because we don't have source meshes right now. We just pass in nil, and this will need to be a try. And we're going to print error if it messes up. So let's let that catch up and make sure it doesn't break. It's going to be happy. I know it is. And now we have our meshes, build model meshes. So our global meshes is now populated. However, it is still any object, so we'll have to remember that. But now we can go down to our renderable. Look, like this is it. This is it. We've constructed it. We'll need to call it build model meshes with the device and the model name of model name, whatever we say, and it's ready to go. Ready to go. Nice. All right. So just like these other, like when we did primitive, see we set these model constants. We have the set render pipeline state. So yeah, I'll just take this. No, I'm not going to take it. But yeah, so we're going to set the render pipeline state, set the model view matrix, set the vertex buffer, and then draw the index primitives. Now the setting of the vertex buffer will be the meshes vertex buffer, because the mesh now has a vertex buffer, and it's populated with whatever the hell data we give it, and then we will draw the index primitive of all the sub meshes. So let's do that. Let's do that. We need model constants. Var model constants equals model constants, just like so. Simple. Don't you yell at me. All right. So command encoder. Dot set render pipeline state to our render pipeline state. First things first. Next, let's do our model constants. So model constants dot model matrix. Actually, model view matrix. Let's go update this because now we're setting the model view matrix, and I'm gonna have to do that everywhere. Copy. I think I did that in primitive. So model view matrix right there. Plain. Just make sure. Just go through these. Turn model matrix. Well, node. Yep. So our node has a model matrix. Yep. And then the model view. Yep. V. 9. If it equals model view matrix. Okay. See, so now it's a little more standardized, and then we'll also go into our shaders and make sure this is called model view matrix because we're passing in the model view matrix. Copy. Find model matrix right there. Looks like that's it. Okay. So now we'll go back into our model, just because it is model view matrix. Just thought we update that. All right. Now we're gonna set that. So command encoder dot set these bytes. Set vertex bytes to the reference of model constants. The length is going to be memory layout of model constants dot stride at 0. This, wait, no, this isn't at 0. I think this is at 1 if I remember correctly. Let's go buffer model constants at 1. Okay, set those at 1. Boom. Okay, so now we've had that basicness set up. Next we're going to need to, so our model constant. Let's put set the vertex buffer. So in our primitive, you see we set the vertex buffer. Let's do that now, except we need to go through all of our meshes. So our meshes is an array of like meshes, of sub meshes, right? So we need to go through all of our meshes in the whole array and set the vertex buffer for each mesh inside of it. So let's do that. But in order for us to do that, we need to declare meshes as a real type so we can call functions on it. And we can do that using a guard. Let meshes equals self.meshes as an array of mtk mesh. And then we're going to make sure that the meshes.count is greater than 0, else we're going to get out of here. We're going to return. Okay. So we're making meshes equal mtk mesh. Like we're giving it a type, because right now it's any object. We want to give it a type, an array of mtk mesh. That's what it is. So it's going to cast it there, and then we're going to make sure that the count's greater than 0, because we do not want to render stuff if it doesn't have, we don't want to continue if the count is greater than 0. So for mesh in meshes, let's set, so let vertex buffer equal mesh dot vertex buffers at 0. We're only going to have one vertex buffer. Dot buffer. So you got to say like vertex buffer dot buffer, because there's other stuff that, like, you have the offset of this vertex buffer, you have the name, the length, all that stuff. So you want to call the buffer on it. And now we have a vertex buffer, so we can go command encoder dot set vertex buffer right here to vertex buffer for the mesh, offset of 0 at 0, because the vertex buffer is at 0. Same vertex buffer, we're just setting it at 0. Okay, now draw index primitives. Our meshes, submeshes have that, so we're gonna want to go for submesh, or well, for mesh dot submeshes. That's the array for submesh in mesh dot submeshes. Oh man, this tree. We're gonna draw the index primitives for this guy. So command encoder. Oh boy, command encoder dot draw index primitives. And let's make this more legible and easier to type. So all of this jazz, the submesh knows what it is. So we just have to call submesh dot, what is this type? Primitive type. Primitive type. Look at that. Submesh has it. Index count. What do you have it? I don't know. Does submesh have it? Index count? Oh, you do. You're such a sweetie. That was, so now we'll need submesh dot index type. Will be whatever it comes through in the file. We have the buffer, which is the submesh dot index buffer, and like I said, we need to call dot buffer. And then the offset is going to be submesh dot index buffer offset dot offset. Boom! Look at that. I think that's going to do it. That's our file. That's what's up. For now, we'll add texturable in a second, but I think, pretty sure that's like how it should be. I'm going to save this and save this. Let's just build. Make sure that all of those model view matrices are accounted for. All right. Yep, so it's back to everything's fine. It's doing its thing. But now we have a model. So sweet. Let's utilize this model. Let's go to our basic scene and get rid of some stuff. We should probably, all right. I'm gonna change this to movable object so that I never have to rename it again. Okay, I'm gonna get rid of the wall. Get rid of the wall. We don't care about the wall right now. We're gonna add a movable object. So this will be movable object, copy, boom. Then we can just change this. Be a lot easier. I'll even rethink this too, and maybe there's a better way. So anywhere C is located, like right here, like this model, we could just say movable object. Position, camera, cool. So now we have movable object. Everybody's happy. It's a cube right now. But one other thing before we start rendering a model is that I want to add 2 more inputs, and that's for rotation for the model. So we can rotate it like left and right, so we can kind of view it. So movable object dot rotation dot y. I don't know what you're thinking. The key, we're going to rotate around y, so it kind of spins around. The key is not right? And you are absolutely correct. So we need to go 3, 4. And these don't exist right now. So let's go to input handler and add 3 and 4. Like literal key 3, key 4. So that we have at least some form. I'm going to go remap these at some point so we have something that's more intuitive. But for now, this is going to work. Man, my eyes are itching. I don't know what that is. Yep, so now we have rotation, and then we'll have minus equals speed, so it goes the opposite direction. And boom. All right. The moment you've been waiting for. Model. Right? Model. All right, and now we just need the model name. This is not image name, this is model name. And we're going to do the armadillo first. Just like so. And then we need to add child movable object. Just like so. Let's run this, see what happens. Oh, broken. Let me see what's going on here. Oh, 19 to 20, and then we'll need 21. I think those are right. Just because 1 and 2 are 18, 19. I'm assuming it's just going to go all the way up to 0 in order. All right, so we broke. Breaking. All right, this says, probably try to unwrap nil. Found nil. Why are you nil? What's going on? I'm assuming it has to do with this being not in a group. I guarantee that's what it is. Alright, I'm deleting you. Move to trash. We'll add you one by one. I believe it's because it wasn't in a group. So I'm going to call this models. It's going to be a picture of a bunch of models, sexy ass models. Not true. And I'm going to add one at a time. Copy items, create folder references if we need them. Okay. So now I have armadillo. Let's run this now and see if it yells at me. Screams in my face. Oh! Oh! Dude, let's use 3 and 4. Oh, gee. Oh, that speed's way too fast. That is ridiculously fast. I'm going to go back. Hold on. You can keep playing with it. I don't control your screen. I'm going to call this 0.05. He has color, bro. It's also white, which is kind of weird. Go Stanford for making a sweet looking model. Oh, yes. Let's like move him around. Oh, and then, oh, the pièce de résistance. The wireframe. Oh. Oh. Look at that thing. Look at how many vertices that thing has. Oh my God. We can't do this by hand. We can't. I mean, if you want to, you can try. I'm not gonna. Go Blender. Go Stanford for creating this so we can play with it. Oh, dude, look at that. That is gorgeous. That is so freaking cool. Look, we're rendering models, people. If you're not excited about this, just unsubscribe. Uninstall. Do whatever. Because this is so cool. My computer's freaking out. It's like, oh, you want me to draw how many vertices? Are you kidding me? I need a new computer. Let me see here. So, yes. Look at this. Oh, I'm just playing. This is so cool. All right, so now that we have this guy, just doing his thing. Let's see. Let's go. Oh man, that's so sweet. We don't have any lighting. You see how he, like, as of right now, we don't have any lighting, so he's coming out kind of blank. Once we have lighting on this creature, this armadillo, we will then, once we have lighting on him, we'll be able to distinguish his face and all of his features and his muscles. But we're not doing that in this episode. In this episode, the next thing we're going to do is let's give that thing a texture, whatever texture we pass in. So we can call model name and texture name. So let's go to the model, and we're going to add another parameter for the initializer called image name. And this will be the texture that gets applied. So if image name does not equal nil, or how about string.empty? Let's just make it that. Then let's create a texture. So we're gonna say if let we need it. That's I was thinking. Like, what the hell is going on? Extension model texturable. Right, so now it's a texturable. We actually don't need to do this. We could just go like this because it doesn't actually have anything that needs. It will need a texture. So var texture, and then that's what we're doing. If texture equals set texture device image name, and I'm gonna call else texture equals null. Kind of is nil already. I'm just gonna keep it at nil. All right. So I'm also going to go down here, and we're gonna set it. So I need to go if texture does not equal nil. We'll need to use a different the fragment shader. We'll say command encoder dot set fragment texture, which will be texture at 0, and then we'll also need to go up here and use the different fragment function. So this, and then fragment function name equals, let's go into the shaders and grab that, or is it textured fragment function? Really need to start organizing this code. And yeah, so let's just run it without a text. Oh, it's gonna break. It's gonna say go to hell. It needs this other parameter. So we're gonna take in the image name, and then that's going to be nothing. Let's make sure it sets it to nil. Just don't want it to break later on. Man, my eyes are so freaking itchy. I don't get it. Make sure it still goes. Yep. Cool, there he is. Now let's wrap him with a texture. Let's say, let's see, stone.png. Let's see. That's the only other one I have. Well, I have smiley face. We can wrap him with a smiley face. Let's see if he gets wrapped. Oh, you can't see it. Oh, look at that. That's weird. So he's like continuing because it doesn't have all the texture coordinates it's requesting. It has it right there, but then it's like, I don't know what these texture coordinates are. These aren't real things. Don't lie to me. And then we can also do like smiley. Like, we'd probably want to make a texture that makes sense on an armadillo. But it's like these texture coordinates aren't real things. You're lying to me. I do know my own little part. So it looks like they start right there, and I'll look more into this. Look at it. That is one fierce looking armadillo, if you ask me. So this is like if you want to apply some like clothing to him or something, or like just a rough something texture. We'll do a different one. Let's do let's go to our the F16 had a texture. We'll put the f16.obj in there, and then the images we're gonna put that BMP. Don't know. Oh yeah, so let's try that. I don't know if this is gonna work. Might need to look into this a little bit more. So if I go image name equals so we're gonna use the model of F16, and then we're gonna use the F16's dot BMP. Let's see if this works. Oh boy. Look at that, huh, peeps? Oh. Man, I really need to get rid of this. So, that is cool. So, let's get rid of all this lighting and stuff so we can see it. And let's do this UI stuff that I said I was going to do at the beginning. All right. So, let's make a new class called preferences. Make this more manageable. This is ridiculous. Preferences. Gonna be all of our preferences. The only thing right now we have, I'm gonna import just in case we need like float 3 or something, metal kit. And then I'm gonna say class. No, let's make it a struct. Preferences. And then the first one I'm gonna do is var wireframe. All right, well, use wireframe. That'll be a Boolean. We will set that equal to false initially. Like this will be our default. And I want to make it static so it's accessible everywhere. See that? So now we have use wireframe under preferences. It's static, so we can call static.useWireframe. And in our renderer, which is freaking doing things we don't want, like this is a renderer. We don't want to toggle wireframes here. Right there. It was also called from our metal view. So right here, we're not going to call renderer.toggle wireframe. We're going to say preferences dot. Come on. What are you doing? I'm not going crazy. Preferences dot. What is this? What are you doing? Middle view. Pretty sure this should work. What am I doing wrong? Oh, let's save it. Does that work? Yeah. So use wireframe equals, well, we're just gonna toggle it. Preferences dot use wireframe, and now from our I think, is it renderer? We call if wireframe on. No, we'll say if preferences dot use wireframe, then set the triangle fill mode. So now I think if it doesn't scream at me, we'll have an easy way to access whether or not something's on from all different classes. I don't know why I didn't do this before. Oh boy. So it's using the wireframe apparently. I don't want it to be. Why are you doing it already? And then like it turns it on and off, but use wireframe. Did I set it to true? Well, it's initially on. The checkbox is on. Oh, well, I should set the defaults, I guess, on my preferences. So preferences, false. Oh, because that's right. In my view controller, where I toggle this wireframe, that's annoying. I want to put that on the... Screw it. I'll just keep it here. So this we can probably just call... I don't know if preferences dot use wireframe. Yeah, equals not preferences dot use wireframe. So we'll call it from here, and then our we don't even need to call it from the view. So we only need to call it in one spot, and then wherever we're so in our view controller, this won't matter. It'll only be where our defaults are. So when we have, we'll have to add a click for everything in this view controller, but it will set the preferences. Yeah, that's perfect. Don't break. Use wireframe, so it's not using the wireframe, and now it should be, yep. So it's working exactly the same, except we don't need to make like 15 method calls. We can just call preferences.use wireframe. Clear color. I want to change the clear color. So let's go to here. Let's go to our other. Let's put preferences up here. Go to our main storyboard. We have wireframe. I want a clear color. Now they have something called a color picker. Color well. That's what I want. Okay, I haven't done this. I just thought of this. I think we're gonna put a label on this thing too. Label. Put that right next to it. So this will be clear color. I'm gonna organize this better. You can organize it however you want right now, to be honest. So that's gonna be clear color. You're gonna go right there. Let's just make these things look nice. So we're gonna go horizontal spacing. I'm gonna do vertical spacing, Clear color will also have this. So boom, now let's apply Command A, and then we're gonna go up, add missing constraints. It's gonna do its thing, and now let me just make sure that shows up correctly when we resize. Cool, so that's all good. Now our clear color should now update. So let's do this guy. Okay, so I'm gonna take a second. Let's go to view controller. Take this, when I change this, so change clear color, action. We're going to call this, what is it, color well? So color well, see well, CW. I need to call this clear color well underscore clicked or changed. Put that right here. I might have to Google some stuff. Don't remember how to do this. I know we can do this though. We're gonna need to actually make this a property so I can call on it. I'm gonna call it clear color well CW. Clear color well. Connect it. So now we have clear color well. And at the beginning, I'm definitely going to do this though. So let's see. What do we want our initial color to be? Our initial color is going to be, let's use this color well to select like a blue or something. I don't know. No, something more. Let's just do white. We're going to do straight up white sun. I'm gonna do that from this drop down. No, now white. So it's gonna start as white, and then we'll go to something else. But if I want to change that, it's easy. We could just say main metal view dot clear color equals CW clear color well dot color. Maybe it needs to be yeah, so this is gonna say types are wrong. It needs to be NS color. I think there's an easy way to do this. I'm gonna make a function. You know what? We're just gonna do it in the preferences. So we're gonna say static var clear clear color as a mtk clear mtl clear color equals I don't know, can I say that just so it's not nothing to begin with? Is that okay? You're gonna yell at me? Oh yeah, cool. So now I can say static, well, public static func set clear color. This will be an NS color, so color is an NS color. And then I can say clear color equals MTL clear color, and then the red I'll just do color.r color.g green component, red component, blue color.blue component, color.alpha component. Then it's gonna probably want to cast all these things. Yep. So let's cast them. Bum bum. You don't want to cast anything else? You done? Oh. Being lazy. And one more. Alright, let's see if that doesn't break everything. Can't be nil. So let's, oh yeah, well I guess it's default, so let's call it MTL clear color, and I'll just make it white, like I said. So red, so 1 1 1 1. There. So now it's white, and then we'll set the clear color to whatever the hell value we want. Let's now we can go here and say preferences dot set clear color to clear color well dot color. It's not gonna break, it's happy. Now I'm gonna just go swift dot print hello. Just make sure this color thing's changing. Actually, sender.color. I wonder if sender.color. Sender.color. It's gonna say go to hell. I might need to look this up. I just need to make sure that when I change the value, the color value, I can call set clear color. It won't actually be white yet because we didn't use it. I just want to make sure this works. We're going to link it all together, peeps. What are we running? 104. Let's finish this up soon, huh? Huh? Okay, so the clear color. So if I go here, opens that. Yeah, so it'll change that color. I just need to kind of figure out how to get that color. And then I also need to set it. So renderer. Let's go to renderer, the very first thing. Set triangle fill mode. I'm just gonna do it right here, right at the top. There. So now that's done. Gonna go back to the view. Get rid of this clear color bullshit right there. That way it's not hard coded. You can do whatever the hell you want, but it won't change. It won't change yet because it'll only print hello. I just want to make sure that it changes it to white. It doesn't break. Okay, so let's zoom out. Yep, so now we have a white, and we still have some light stuff. I'm gonna make a boolean for that, but let's just get this color thing to work. I need to get color well, color changed, Swift. Let me see, how do I change the color of my picker? Let's just see, first top view. Get text for picker. I need on change. Nobody answered this. Bow. How to change the background color of UI button. Swift UI view background color. Got placeholder, smart color, something. Hold on. Alright. Swift color well on changed. I'm gonna let me see. Color and transparency. Nobody's helping with anything. Come on, Ray. Swift, what is it? Is it called a color well? It's called a color well, right? Why do you always do that? Go to my view controller. NS color well. Let's type in NS color well. Swift. NS color well on changed. Sure, we'll do Objective C, which I can't read. Method 2, add observer for color options. Yeah, I wish I knew Objective C. Documentation, which is Apple doesn't really do a good job of making it easy to read. Sorry guys, should only take a few more seconds. Should be freaking easy. They have any object, but I don't want it as an any object. I want it as a well, here, let's do what it said. Preferences dot set clear color to sender dot color, and then let's see what it has me fix. Oh, we can just do this. We can go CW clear color well dot color. Haha. Why did I Google all that? Maybe. So now, and then there's just that. This is the hard one. This is one of the hard ones. That okay. So we zoom out. It's white. Now let's select like, ooh, clear color changes. So that'll be cool. Now we just need to add types. Light. So var use lights equals false. Don't use lights first. Looks good to me. Let's go to the shaders. Let's go to light. We're gonna go bool use light. And then we're gonna say right here if you light dot use light save that. Now in our we need to add a new checkbox. Just copy this one, copy, paste that guy right there. Do the same jazz where we go control, just right there, horizontal spacing. Oh boy, that's not what I wanted. Right there, vertical, bottom. Looks good. Wireframe off, but we want use lighting. Preferences, var, right. Static var, use lighting, bool, equals, false. We want to set false first. Defaults, people. Okay, so now we have use lighting in our renderer. Oh, it's scene. Light.use lights equals preferences dot use lighting, and we just need it on change button click. Give me that. What are you doing? There it is. And then we just need you to toggle. Put it under. Check use lighting clicked. It's an action. Now I'm just gonna need to put this up here. No, I don't even need that. I just need to go exactly what I did here. So preferences dot use lighting equals not preferences dot use lighting. Okay, so there's that. Now I just need one more. Just make sure this works. Sorry, I'm going kind of fast now. There's only one more thing that I kind of want to do, and that's use to toggle whether or not I'm on a computer or not. But okay, so here we go. So oh, that's weird. That's really weird. Okay, I might do this one. Renderer. If, oh. Maybe that's too much of a call. What's in my shader class? If light.use light. Just a bool. Let's hit this, see what's going on. Debug. Oh, this is gonna be a long video. Sorry, peeps. We want. How do I check this thing? It just occurred to me, I have no idea where to look for this thing. I need to know if this is true, and it won't tell me. I'm used to Visual Studio, huh? What are you right now? Alright, well, I'll learn to debug this week. God. This is such an immature move. Alright, so let me see. Use lights, preferences that use lighting. So I'm making this call every 60 times a second. Should I be doing that? For that call, what I can do, sorry, it's really All right, so if no, it needs to be that. It's something else. Something else is weird. It's like data inconsistency. It's a Boolean, but I don't know if I can be passing a Boolean. Like when it gets here in the shaders, I don't know if I need to cast. See, it's use light as a Boolean, but what does that mean on this side? So if light use light, okay, let's just get rid of this use lighting thing for now, and then I'll keep commenting it out, and I'll figure it out off screen time. And then we'll do that real quick next time. And let's just go to types. Let's get rid of this use lights, false. Sorry guys. And then we'll go to our preferences. Use lighting, I'll get rid of this. And then I'll get rid of it one more place, which is right here. Check use lighting. All right, now everybody's happy. Let's build it, run it, check out the coolness of it. I'm actually gonna change it. I don't like, this jet's okay, I guess. Oh man. Yep, get rid of this, light dot use light. That's probably where it broke. But, oh well. Yeah, that's probably exactly where it broke. Huh. Yep, so we have that, and then we're gonna go to our red, check out some cool shit. Let's do the armadillo again. Armadillo. You're gonna be on scene. Image name, I'm just gonna pass in nothing. Forget the F16, the armadillo is my favorite. Armadillo. Then I'm gonna get rid of the lighting. Like manually. And let's check out this badassery. Oh, it's so sick. Okay, so probably what I'm gonna do next time is instances, because you can imagine if I tried to load this thing up, like if I wanted 5 of these little monsters running at me at a time, then it would be really, really heavy on the GPU if I just loaded every single one of these vertices every single time I needed it. So what Apple has is something called instances, where you create just one model and then you replicate using that. Like you use those vertices over and over and over again. So we'll probably do that next time. Let's make this just a little cooler for now. I know I just changed this, but I'm gonna make this clear color equal black. And then I'm also going to go into the shaders.metal, and just for now, next time we'll change this back, but I'm gonna go, well, it's not gonna use this one. It's going to use this one. We'll just say color equals vn.color, screw that. We're gonna go color equals float 3, well here. Do that, and then I'm gonna go float for color equals float 3, and I just want it to be white because it will probably look cool, because then we won't see like all the different colors. We can just see the white vertices being drawn. Oh, and float, obviously, God. So just set it to white, and we'll see this final product. So yeah, we'll go into instances next time, where we can draw 100 million of these things, as much as we want. Not as much as we want, but a lot of them. Oh yeah, see, that's way cooler. Look at him. He's white, Check out his wireframe. Oh, it's so easy to see now. And we go inside of him and rotate him. Oh, oh, that's so crazy. That's so cool. All right, so hope you enjoyed it. That was kind of fun. That was really fun. That was freaking epic. And let's just do one more thing. One more thing. Thinking here. So the basic scene, we're gonna do movable object rotate around the y-axis just to make him look cool. Like, so he's epically rotating because he's an armadillo. Can't wait to make this guy like punch. I don't know how to do that as of now, but we'll get there. One step at a time. Sorry this episode was so long. Worth it though. Yep, now he's freaking sweet. Let's make this full screen. Oh yeah. Oh yeah. Oh man. And let's put on the wireframe. Oh Jesus. Look at him. Alright, Pete's. Thanks for joining me. See you next time. I'll see you when I see you.